Imagine a time machine. Not one made of gears and flashing lights, but one made of gold-plated mirrors, sailing silently through the void of space. This is the James Webb Space Telescope. It is humanity's most powerful eye on the universe, launched on Christmas Day in 2021. Its mission is simple yet profound: to look back in time. It seeks to see the very first stars and galaxies flicker into existence, to peer through cosmic dust clouds where new worlds are born, and to search for the chemical fingerprints of life on distant planets. It is a monumental achievement of human curiosity and engineering, a testament to our unending desire to know our place in the cosmos. Why is this telescope so special? It sees the universe in a different light, literally. Webb is designed to detect infrared light, which is essentially heat. This is the light emitted by the most distant objects in the universe, a light that has traveled for billions of years across expanding space. This journey stretches the light waves, shifting them from visible light into the infrared spectrum, an effect known as redshift. Webb's giant 6.5-meter primary mirror, a honeycomb of 18 hexagonal segments, collects this faint ancient light. This allows it to see things that the Hubble Space Telescope, its amazing predecessor, simply could not. It is our key to unlocking the universe's earliest secrets. Think of the universe as a grand cosmic story. For decades we had read many chapters, but the first few pages were missing, torn out by time and distance. Webb is our tool to find those missing pages. It can pierce through the dense curtains of gas and dust that hide stellar nurseries, revealing the chaotic and beautiful process of star and planet formation in breathtaking detail. It can analyze the atmospheres of planets orbiting other stars called exoplanets, looking for water, methane, and other molecules that could hint at the possibility of life. This isn't just about taking pretty pictures, it's about answering the most fundamental questions we can ask. Where did we come from? Are we alone? The telescope orbits the Sun 1,000,000 miles from Earth, at a special point in space called the Second Lagrange Point, or L2. Here it can keep its back to the Sun, Earth and Moon, allowing its sun shield to block their heat and light. This is crucial. To detect the faint infrared signals from the dawn of time, Webb's instruments must be kept incredibly cold, colder than any freezer on Earth. This orbital position and its 5-layer, tennis court-sized sun shield are the keys to its power. It is a marvel of thermal engineering, a lonely sentinel in the cold, dark expanse, patiently gathering photons that began their journey when the universe was just a baby. One of Webb's first and most shocking discoveries has completely upended our theories about the early universe. Scientists expected the first galaxies to be small, faint, and disorganized. They believed it took a very long time, hundreds of millions of years, for gravity to pull together enough gas and dust to form the grand, structured galaxies we see today. But Webb looked back to just 300 million years after the Big Bang and saw something impossible. It found galaxies that were incredibly bright, massive, and surprisingly well-formed. This was like finding a fully grown adult in a nursery full of newborns. It challenges everything we thought we knew about how quickly the universe got to work building things. These early, brilliant galaxies suggest that the processes of star and galaxy formation were far more efficient and rapid than our models predicted. It means the cosmic dark ages ended sooner than we imagined, and the universe was lit up with starlight much earlier. Webb's deep field observations, like the JADES program, have found a treasure trove of these ancient cosmic structures. This discovery forces us to rethink the very physics of the early cosmos. Perhaps the nature of dark matter is different than we thought. Or maybe the first generation of stars were far more massive and luminous than we ever conceived. Webb hasn't just given us a new picture of the early universe, it has handed us a brand new puzzle to solve. Closer to home, the James Webb Space Telescope has also proven to be a vital guardian of our own planet. In early 2025, it played a critical role in assessing a potential threat. An asteroid named 2024 YR4 was discovered on December 27, 2024, just 2 days after it had made a close pass of Earth. Because it came from the direction of the Sun, it was hidden in a blind spot for our ground-based telescopes, a frightening reminder of our vulnerability. Initial calculations were alarming, suggesting a non-zero chance of it hitting Earth on a future pass, briefly giving it a concerning rating on the Torino scale for impact hazards. Humanity held its breath. Swiftly, astronomers turned Webb's powerful gaze toward the small, fast-moving rock. Its precise infrared observations provided crucial data on the asteroid's size, composition, and, most importantly, its trajectory. Webb's measurements were so accurate they definitively ruled out any chance of an Earth impact for the foreseeable future, a collective sigh of relief for the entire planet. However, the story didn't end there. Webb's data revealed something else. A small but real 4% chance that this 60-meter-wide asteroid could strike the Moon in December 2032. This event showed Webb's dual role, a tool for cosmic discovery and a powerful instrument for planetary defense, helping us watch the skies and protect our homeworld. While Webb is famous for looking at the distant universe, it also gives us a stunning new perspective on our own cosmic neighborhood. It has turned its golden eye to the gas giants, including the magnificent ringed planet, Saturn. In 2023, Webb provided the first-ever direct visual evidence of a colossal water plume erupting from Saturn's small icy moon, Enceladus. We knew this moon had a subsurface ocean and that it vented water into space through cracks in its icy shell, but Webb revealed the true scale of this process. The plume it observed was enormous, stretching over 6,000 miles into space, which is more than 20 times the diameter of Enceladus itself. This incredible plume of water vapor and ice particles is actively feeding Saturn's faint outermost E-ring. Webb showed us a direct connection, a cosmic umbilical cord between the moon and its parent planet's ring system. It was like watching a donut-shaped cloud form in real time around Saturn, all sourced from the hidden ocean of this tiny moon. This discovery is more than just a beautiful sight. It reinforces Enceladus as one of the most promising places in our solar system to search for life beyond Earth. Where there is liquid water, energy, and organic molecules, all of which Enceladus seems to have, there is a tantalizing possibility of life. Webb is also helping us tackle one of the biggest mysteries in modern cosmology, the Hubble tension. For years, scientists have been puzzled by a major disagreement. When we measure the expansion rate of the universe using observations of the local nearby universe, like supernovae, we get one number. But when we calculate the expansion rate based on the light from the very early universe, the cosmic microwave background, we get a different number. This discrepancy, known as the Hubble tension, suggests that either our measurements are wrong, or our fundamental understanding of the cosmos, the standard model of cosmology, is incomplete. It hints at the existence of new physics we don't yet understand. In 2024, a landmark study used data from both the James Webb and Hubble space telescopes to make the most precise measurement ever of the local expansion rate. The hope was that Webb's superior clarity would resolve the tension, perhaps showing an error in the previous Hubble data. Instead, Webb's findings perfectly aligned with Hubble's, confirming that the discrepancy is real and not just a measurement error. By confirming the Hubble tension, Webb has deepened the mystery. It has solidified the evidence that something is missing from our cosmic theory, pushing scientists to explore exotic new ideas about dark energy, dark matter, or other unknown cosmic ingredients. The James Webb Space Telescope continues to peer into the most extreme environments, including the graveyards of stars. What happens to planets when their sun dies? For stars like our own sun, the end comes when they swell into a red giant and then collapse into a dense, Earth-sized remnant called a white dwarf. It was long debated whether any planets could survive such a violent end. Using its powerful mid-infrared instrument, or MIRI, Webb has found compelling evidence that they can. It has observed white dwarf systems and detected signs that suggest planets, or at least the rocky debris of planets, may be orbiting these stellar corpses. This is a profound discovery. If confirmed, it means that planetary systems can be far more resilient than we ever thought. It opens up the possibility that even billions of years after a star has died, some form of world could persist, perhaps as a cold, dark rock orbiting a ghost star. This changes our perspective on where we might look for habitable environments in the very distant future of the universe. It tells us that the end of a star's life is not necessarily the end of its planets. This is another example of how Webb is not just answering old questions but is opening up entirely new fields of inquiry, forcing us to imagine cosmic scenarios we had never before considered. The close call with asteroid 2024 YR4, while resolved by Webb, served as a stark warning. Our planet has a dangerous blind spot. We cannot easily detect asteroids coming from the direction of the sun. This event has added urgency to the development of new missions specifically designed to fill this gap. Future observatories like NASA's NEO Surveyor, scheduled to launch in 2027, and Europe's Neomir mission will be placed in orbits that allow them to look toward the sun and spot these hidden threats. These missions are the direct descendants of the lessons learned from near misses, designed to give us weeks or even months of warning, rather than days. Webb showed us the power of a space-based sentinel, and now we know we need a dedicated fleet. In just a few short years since it began its mission in July 2022, the James Webb Space Telescope has fundamentally altered our cosmic perspective. From finding impossibly early galaxies to witnessing a moon feed its planet's rings, from confirming a deep cosmic mystery to helping defend our home, its impact has been revolutionary. It has shown us that the universe is more dynamic, more surprising, and more magnificent than we ever knew. Webb is more than a machine of discovery, it is a machine of inspiration. It is the beginning of a new chapter in our exploration of the cosmos, promising decades of incredible science that will continue to reshape our understanding